Hi, in this video, let's look at your Form 4 Monomath textbook, Cell Practice 1.1c, page 14. Question number 1. The quadratic function below passed through the point stated. Calculate the value of c for each case. Now, for part A, given that this function f of x is equal to x squared plus 7x plus c passes through the point 0, 5. So what is the value of c? This is x coordinate, this is y coordinate. Or this is x, this is f of x. It's actually the same thing. You can just change the f of x become y is equal to x squared plus 7x plus c. Now, what does this mean? It means that when x is equal to 0, y is equal to 5, right? So what we need to do, we just need to take the x coordinate, plug in here, and the y coordinate plug in here to get the value of c. So for part A and part B is actually pretty straightforward. You can try it on your own. Now let's look at part C. F of x is equal to negative 2x squared plus x plus c. And the y-intercept of this function is equal to 4. Okay, you need to remember this. On y-axis, the x coordinate will be always equal to 0. On x-axis, the y coordinate will be always equal to 0. So on y-axis, this is y-intercept. On x-axis, this is x-intercept. Since the question tells you that y-intercept is equal to 4, then we know the coordinate of this y-intercept is actually 0, 4. Why? On y-axis, x is equal to 0, right? So what do we need to do? At point 0, 4. So the 4, we need to plug in here the value of y, and x we need to plug in here. Now from here we know c is actually equal to 4. Another way to get this answer is we don't have to calculate actually, because if you have a quadratic function, f of x is equal to ax squared plus bx plus c. This is actually y-intercept. So you remember? So since the question tells you that the y-intercept is equal to 4, so we know directly c is actually equal to 4. Now let's look at question number 2. The diagram on the right shows two graphs of quadratic function. So this one is y equal to f of x, and this one, red color, is y equal to g of x, drawn on the same axis. State the range of values of p, and we want to explain our answer. Okay, now this is y equal to g of x, which is equal to g of x is negative 4x squared plus 3. Now, the question wants us to state the range of p, right? So you try to look at this graph. This graph is actually wider compared with this graph, right? So from here, we know that the value of p is actually smaller than 4. Since, or we can just explain this way, the graph y is equal to f of x is wider compared with the graph y is equal to g of x. Therefore, p is less than 4. Okay, now we know p is less than 4, but this is not the final answer yet. Okay, the graph, or you can write this way. This explanation you can use your own sentence. Since the graph y is equal to g of x. Oh, sorry, y is equal to f of x. Y is equal to f of x is concave down. This set face, we can say it concave down. Concave down or concave downward. Therefore, the p or negative p must be less than 0, right? We know here must be equal to negative. If this is positive, the graph will be smiling face, which is concave up. So this is concave down, so negative p must be less than 0. So from here we know that p is greater than 0. Okay, then we combine these two range together. Our conclusion, p is greater than 0 but less than 4. This is our final answer, the range of p. Okay, now you look at this graph. Now I have a graph y is equal to this is 1x squared. If you don't see any coefficient here, it means 1. 1x squared plus 1x plus 1. So when I change the value of a, this is a. Let me write this one over here. Y is equal to ax squared plus bx plus c. Now, if I change the value of a, the value of a is going to determine whether the graph is concave up or concave down. If this is positive, concave up. If this is negative, concave down. Or we can say sad face, smiling face. Now we just focus on the graph which is concave up. You will notice that when the value become larger and larger, the graph is actually become narrower and narrower, right? Now when the value of a here becomes smaller, it becomes wider. Okay, same thing for negative. Now what do we need? Just focus on this. Ignore about the negative. Negative is just tell you the graph is actually concave down. You will notice that when I increase the value here, it's actually become narrower and narrower. Right? If I decrease this 3.7 become 3.6, 3.5, 2.0, and so on, it becomes wider and wider. Right? Okay. That's why for this question, since the graph here is wider than this graph, therefore we know that the p must be smaller than 4. Okay, now let's go to the question number 3. The diagram on the right shows a graph of quadratic function f of x is equal to kx squared plus 6x plus h. Point A, this is a maximum point. 3, 14 is a maximum point of the graph of quadratic functions. Given k is an integer, so you have to understand what is an integer. Where k is greater than -2 and less than 2, state the value of k. So k is greater than -2 and less than 2. Try to think what are the integers between these two numbers, -2 and 2. So we have -1, right? We just consider integer. So you don't have to think about like -0.5. -0.5 is not an integer. 0, 1. 1.5, we don't have to think about 1.5 because 1.5 is not an integer. Okay, now, which is the value of k? Try to look at the graph here. This graph is actually concave down, right? Sad face. So we know that the k here must be negative. Therefore, we can make a conclusion that k is equal to -1. This one you don't have to calculate, you don't have to show any step, just give the answer. K is equal to -1. Okay, now If k is equal to 1 is actually smiling face, it will not be sad face like this. If k is equal to 0, then this will become a straight line, which is no longer a quadratic function. Okay, now b. Using the value of k from a, calculate the value of h. We know that k is equal to -1, right? F of x is equal to, let me copy first, kx squared plus 6x plus h. And we know k is equal to -1. I am going to bring -1 inside here, into here. -1, you don't have to write 1, you just write negative. Okay, now we want to find the value of h. We can just plug in the coordinate here into here and here to get the value of h. So this is x, this is f of x. It means that when x is equal to 3, f of x will be equal to 14. Or you can just think y is equal to -x squared plus 6x plus h is actually the same thing. At point A, 3, 14. So this is actually equal to 14y. And the x, I will replace them by 3. So before we get the answer, we know the h must be positive, right? If we get a negative answer for h, then we know that definitely our answer is wrong. So this is 14, this is -9. Okay, h is equal to 14 minus 9, which is equal to 5. So this is equal to 5. For the last part, we want to state the equation of the quadratic function form when this graph is refracted in the x-axis. It means that this is x-axis, this is x-axis. So refracted in the x-axis, the graph will go down like this. So we want to give our answer in this form. F of x is equal to ax squared plus bx plus c. Now this is a graph for f of x is equal to -x squared plus 6x plus 5. This is 5, okay, or maybe I enlarge it a little bit so you can see the number 5. Okay. So this is 5, y-intercept is 5, and the maximum point is 314. So is this curve is refracted in the x-axis. So x-axis over here, it means that the graph will actually go down like this. It will become this graph. So we want to find or determine the function of this blue color graph. So how do we get the answer? F of x is equal to ax squared plus bx plus c. Let's go one by one. Now focus on a first. Just now, let me use this. Since this is green color, I will use green color. This one. F of x is equal to -x squared plus 6x plus 5. Okay, now the shape change to smiling face. It become concave up, right? This is concave down. So definitely we know that the sign of A will need to change. Instead of -1, it will become +1. The width of the graph still the same, so we don't have to change the 1, still the same 1, but the shape go to concave up. From concave down, sad face, to smiling face, concave up. Therefore, I'm going to change the sign here, it become positive. Okay, now let's go to B. Now, when you look at this, you have to remember this. For maximum or minimum point of a quadratic function, minimum point or maximum point, the x coordinate will be always equal to negative b over 2a. No matter minimum point or maximum point. Also the same, the x coordinate will be always equal to negative b over 2a. Okay, now I don't know b. I want to get the value of b. This is 3. Let me make it smaller. This is 3, 14, right? And this is 3, negative 14. You will notice that the x coordinate remain unchanged, right? Now, you already changed negative b over 2a. Before this, the a is negative 1, b is 6. Okay, so negative b over 2a. Negative, negative, you get positive, therefore you get 3, right? 3. So now, since you already changed the sign of a, in order to keep the value of negative b over 2a still remain as 3, we need to change the sign of b as well. Okay, can you understand? Now, let's think this way. Negative b, I don't know b, to a is equal to positive 1 now. So from here, we know that the b must be negative, right? Because only the b negative, negative, it gives us positive. If the b is positive, positive, you get negative. Then it will no longer 3, right? Okay, so we know that the b here must be negative. So I'm going to change it to, this is positive 6, now this is negative 6. Okay, so the c is pretty straightforward. C is a y-intercept. Just now the y-intercept is 5 here. This y-intercept is negative 5. So what do we need to do? Just change it to negative 5. Okay, so this is the answer for this question. If you don't understand this, maybe let me explain another way. Okay, I don't know b. Do I see? I know, right? Negative 5. Let's say I want to find the b. Now, let me show you another approach and a method. A is equal to 1. B, I don't know. I just let it be. Okay, and c is equal to negative 5. According to this graph, you know that the minimum point here, the x coordinate for the minimum point remain unchanged, which is equal to 3. That means negative b over 2a must be equal to 3, right? And b, we don't know, we need to find. A is equal to 1. Now, negative b over 3 is equal to, oh sorry, this is not 3. 2 times 1 is equal to 2. Negative b over 2 is equal to 3. Okay, from here we know that b is equal to 3 times negative 2. b is equal to negative 6. We will still get the same answer. So plus negative 6, you will get negative 6. So this is another way to help us to get the value of b. Okay, that's all for this video. See you next time. Thanks for watching. Bye bye.